I designed a CPU that is better than Z80, but at least faster than Z80. So basically, I have a series for my CPU, my 8-bit CPU series. I have a playlist in my channel. So I haven't finished making it. I'm still in the progress of making my CPU. But if you're interested in this, you can look at my series. But today I just want to do like an intro. I just want to show you like how I designed it and like all the chips and stuff. So when I was in 5th grade, I finished designing my first CPU, which is a 4-bit CPU, very simple one. And I kind of wanted to improve it, make it better. But then I realized I could read books, and read books like about like the Z80 or like the 6502 or the 8085, like those classic like 8-bit microprocessors. So I was studying them, but mainly it was about the Z80. And I decided, why can't I design a CPU that's better than that, since I already know like all the aspects of it. So I tried designing a CPU that was better than the Z80. And well, I think I achieved my goal. So why don't we take a look at my CPU? Okay, so this is my CPU. If you zoom out, you see. You see there are different parts of it. First off, we're looking at PC, because this is our first video of our series was PC. It's the first one I made. So if you look at it, you realize there's 2 parts to my PC. Is like a bottom part and a top part. The bottom part is actually like the real PC, the one that controls jumps and like a loading code from program ROM. The top part is more like for loading data from like external RAM, or like loading data from like input and output devices. This can like input and output too. So these are 2 different like types of addressing. So if we look, the next one I made was registers. This is way simpler. As you can see, there's just one part. I have 4 registers, but there's actually 8. But right now I only have 4, since I have the extra 8 are like not general purpose. I have like special purposes for them. You can see there's a reg here. That's not really for anything. This is more like for moving stuff from external RAM. This part is the decoding part for my registers, for like moving it in. For me, I'm decoding it from the data bus. So like in the opcode for my move instruction, you can extract like the move in, move out for the registers. So next video I'm planning to make is my ALU. I'm currently working on it right now. So if you look at this, you realize that this is the register A. This is one of the registers I said that was had a special purpose. And then all these are for like helping it get flags and like jumping stuff. Not jumping, moving stuff. If you look at this, is like the register A. If you look at this, you realize this is the ALU, main ALU, and you realize there's like select chips, input, output. If we take a look at this, we can open it up. You'll see there's a smaller circuit in there. It's for this. This part of the ALU, this part of the CPU, I'm planning to use FPGA. I know the playlist says all from basic TTL chips, but FPGA is technically TTL chips, since I'm writing TTL chips into it. So, anyways, but yeah. So if you look at this, I have add, subtract, bigger or equal less than, add or shift left, shift right. Yes, and complement. I have a bunch of things used. You might be asking why I'm not using like a ALU chip like 74HC181. Well, the reason is just because like I like to design my own stuff, because then I know it's easier for me to use stuff. So okay, anyways, back to the main thing. Next after that is my instruction decoder. So if you look at this, this one is just for like mini instructions. So far my like instruction decoders are ROM, and basically what it is basically there's 16 mini instruction places for every single instruction. So like all these are like control pins, and I call every control pin a mini instruction pin. So what I'm doing is I'm basically making an instruction out of many mini instructions. For example, move would be display reg this and load reg this. That would be 2 mini instructions that I would put in my thing. And then there's 16 spaces, so that there's 16 like cycles to run one instruction. But I can end it early to like let it use less cycles. So this is the main part, like why it's faster than the Z80. Because for a move it only takes 3 cycles, but for the Z80 it takes like 6 cycles or something, or 4. I can't remember. But yeah, so this designing the instruction decoder this way makes it way faster. My previous designs weren't that fast. And then last but not least, well, not really, I have my stack, which is for like jumping and like jumping back. And last but not least, this isn't really part of the CPU, but it's like very important. If you look at this is the address bus, this is the data bus, and then I have some control pins going out. So this is my ROM, and this is my RAM. I also have some other RAM here that I can use to control like other stuff. So yeah, this is my CPU. So after showing you my CPU, if you have any suggestions or ideas, you can comment down below. I'm also trying to brainstorming ideas for an Arduino project. If you have any suggestions or ideas, you can obviously comment down below too. And as I said in the beginning of the video, I have a link in the description below to my 4-bit CPU project. So I hope you enjoy watching this video. I hope you take a look at my CPU series. And thanks for watching. Bye.